I'm going to start now. So I'll be holding this talk in English. Hope that's fine for everyone. Welcome. It's 9 o'clock Saturday morning, and I'll be speaking about something as extremely exciting as testing your backend applications. So what this talk is about is testing every layer of your backend application. And initially, I was hoping and planning to make it as language agnostic as possible. But the way I've been planning to do this is primarily through demonstration. So there will be a lot of code. So I realized it's going to be difficult to make this completely language agnostic. I have to actually show you some code in a language. So the language choice is Java because I'm most familiar with it and I know the tools best. But the concepts are transferable in a great degree to other languages, and some of the tools I'm going to show you are ported to several other languages, and I'll point them out. I'll start with the fundamentals, the very basics, and then I'll work my way up to the more complex topics as I go, so that you can keep track of what's going on, even if you don't necessarily have that much experience with testing or with testing in Java. So first of all, it might be prudent to ask ourselves, why do we test at all? I won't spend a lot of time on it, but it's worth mentioning. We test, I think, primarily for the robustness of our code, right? We want our code to keep working even after we've finished writing it. We want our code to work 3 months after we finished writing it, or 3 years, right? So we want to make sure that our code behaves the way we expect it to do, and that it keeps behaving the way we expect it to do. And if we find bugs in our code, we want to fix those bugs, and then we want to write a test to make sure that bug doesn't reappear later. We want to avoid regressions. And finally, for the modern development project, continuous integration, continuous deployment is a very useful tool, a very useful technique, and a comprehensive test suite enables that. You don't, like in my current project, we deploy automatically to production as soon as you merge your pull request and get. There's nothing manual after you merge your pull request and get. And you couldn't do that if you didn't have faith in the testing suite of your deployment pipeline and of your applications. Because otherwise, you forgot to take something into account and suddenly you've broken production and all your users are angry. So you need testing for these reasons. I'm going to focus on a very simple architecture in this demonstration. You have your data store. You have an application that reads that data store and then exposes what's in it. And then you have another application which consumes that. So concretely, in this example, the data store holds temperature readings. What's the temperature in Celsius at a certain point in time? And the main application exposes that, and a consumer consumes that API and then graphs a temperature graph over time. And I'll be testing. So I'll be testing all the different layers here, the individual layers, the communication between layers, and also the communication out of and into the application. So I'll be trying a somewhat experimental approach to demonstrating this, which is, first of all, this is mostly going to be code. I'm not going to write it right now. I've pre-written it because I wouldn't have time to write it. And what I'm going to do is, I have all my tests, because I'll be focusing on the tests, not the actual real code. I have all my tests commented out. and I have a color scheme where you almost cannot see the comments. And I'll be commenting them in as we go, and this is to make it as easy for you as possible to focus on what I'm talking about right now and not be overwhelmed by everything else on the screen. I don't know if that's going to work out as intended. I hope it will, but please let me know at the end whether it does or not. It's interesting for me, but that's the approach I'm going to take. Yeah, so demo, let's get into it. I will be focusing first on, so I've got a temperature converter test. Full screen that. So can everyone see the font size? Is that fine in the back? Yes. I'm planning to use this color scheme, black text, dark text on white background. If people prefer the inverse, white text on black background, I can change. Hands in the air if you want me to change to the dark one. No? Okay, I'll keep it. And also I'll be trying to keep, I see it's not as big of an issue here, but I'll be trying to keep the most important stuff to the top so you can, like, it's more difficult to see the text at the bottom. Right, so we've got a temperature converter, and in fact I can show you that temp because it's trivial. And what it does is basically it just converts from Celsius to Fahrenheit or from Fahrenheit to Celsius via the known formula to do that. So I've got a test to check that that works as expected. So to do that, since this is Java, I'm using JUnit. That's where this test annotation comes from. That's JUnit. JUnit is, for those of you who are not aware, it's the test framework for Java. Everything else is written around JUnit. All the tests run with JUnit. All the different libraries are just dependent on JUnit implicitly. The tests, I find it's useful for the test. So the tests are basically just methods, right? A test is a method, annotated with the test annotation. I find it's useful for the test method name to be a brief sentence describing what the method is testing. And it doesn't matter if the name is long, because you're never going to explicitly call this method. This method is only implicitly called via the JUnit test framework. So I find it's useful to have descriptive names for this. So in JUnit, apart from being the test framework that runs tests, it also provides you basic assertions. So here I'm asserting that the value 32 is equal to the output of calling Celsius to Fahrenheit on the temperature converter with the argument 0, and that the output must be within like a 10,000th of what I'm expecting. So this is a simple equality check, and you can run it, and if it's okay, the test will pass. You can see tests passed, it's all green ticks. So that's like the most basic Java test. Equals, assert equals. And you can, I've done the same for a couple of other values. 100, I expect this back. Negative 100, I expect that Fahrenheit. So this is useful. You've got, on the left, you've got the expected value. On the second parameter is the actual value. But I'm going to show you an alternative to this, an alternative assertion library, which is called Hamchrist. You may be familiar with it if you are familiar with testing in Java. So Hamchrist does it in a different way. In Hamchrist, you have a generic assert that, which everything calls, like every assertion starts with assert that. And in Hamchrist, the parameters are the other way around. The actual value is the first parameter, and the expectation is the second parameter. So when you convert Celsius to Fahrenheit, 0 Celsius to Fahrenheit, then you expect the output to be equal to 32. And you might be wondering, why bother using Hamcrest? Because we're expressing exactly the same thing, only slightly differently. And also the different other tests here, it's all the same, just different values. I'll be showing you why I think Hamcrest is the superior choice. So we can go to the Hamcrest demonstration. So first I'll show you basically all the different assertions that JUnit is capable of, because it's not that many, to be honest. You've got assert equals, like I already demonstrated. Two values are equal to each other, or they're not. You've got the inverse, which is a separate function called assert not equals. You've also got assert that two objects are the same, they are identical, the very same objects, or they're not. You can assert that a value is null or not. And you can assert, obviously, that a condition is true or it's false. And if all else fails, you would use those, right? If you have no other assertion that does what you need, you just perform a Boolean test and then you assert on the output of that. And then you can also check whether an exception is thrown as a result of an action. So this is an anonymous function. The anonymous function will be called, and then you expect that an exception will be thrown. So this is basically, these are all the assertions you have in JUnit. You also have fail, which just automatically fails your test, which is useful in some cases. Previously, you would also use in JUnit this is the old way of asserting that you have an exception, which is on the test annotation level. You just expect that the test will fail with this exception. However, assert throws is more useful because you can keep asserting things after the exception has happened. How would you do these things in Hamcrest? So assert equals, we have seen assert that foo equal to foo. It doesn't read that well, so you have assert foo is equal to foo. Is doesn't do anything, it's just there to make your assertions more readable. You can also use is without a matcher, just with a normal object input, and then it means the same as is equal to. And you've got the negation. So in Hamcrest, the negation of a match is not its own. It's not like not equal to, as it is up here with JUnit. In Hamcrest, it's its own matcher. It's a matcher that takes a matcher input. So you've got asserting that two objects are the same. Object is the same instance of object, or an alias of that object is the instance object. So remember, these are just examples. Normally, you wouldn't be hard coding both the left and the right argument here. Normally, the left will be the result of some function you've called. So you're only controlling the right argument. You're not hard coding the left argument. And you can negate whether the check that two objects are the same. You can check that something is null or is not null. For some reason, not null is actually its own matcher, maybe because it's so common. And you can check that something is true or false. That's just equality checking with the Booleans true and false. Finally, Hamcrest doesn't have any explicit provision for asserting that something has been thrown, so you would use the JUnit way of doing that, because Hamcrest only works with JUnit anyway. However, the reason you would use Hamcrest is because it provides you a lot more. With Hamcrest, so the most basic assertion is that the actual value is anything. It's whatever, you don't really care. You might, like, there aren't that many cases you would use it, but if you need a matcher, you might use that. For strings, you can assert that something is an empty string. It's empty or it's null, because empty string would fail if it's null. It's blank, meaning it's white space only, or it's blank or it's null. You can assert that a string starts with a certain string, or ends with a certain string, or contains somewhere inside it a certain substring. Similarly, you have all the same ones, but ignoring case. Case insensitive starts with, ends with, contains, ignoring case. You can check that a string contains certain substrings in order, or that they are equal ignoring case, case insensitive, or you can check that two strings are equal if you normalize the white space. You trim away trailing and leading white space, and all internal white space is compressed to a single space. So running these, the test passes, but if you change, actually let's try this one. You would see that if it, obviously that actually does work. If it fails, you get very useful descriptive failure messages. You expected a string that contains Tom and Riddle in that order, but the string in fact was this. So this is very useful as you get complex matchers. It's much easier to see what goes wrong as opposed to just assert true. If you're writing just JUnit, assert true string dot contains blah blah blah, and all you get is expected true got false. So you have to do all the debugging manually. So one of the greatest strengths of Hamcrest is good failure messages when a test fails. So you've got also a number of useful assertions for iterables. You can assert that an iterable is empty or not, that it has a certain size, that it has a certain item, and that many of these matchers can take other matchers. So you can check that it has the item 2, but you can also check that it has an item which matches another matcher. It has an item which is greater than 2, in this case 3. You can check that it has several items. So here, the order doesn't matter. You check first that the list has the item 2, and then the list has the item 1. And again, this can take other matchers. It has an item less than 2, and it has an item greater than 2. You can check the same as has items, but the order matters. It has items 1 and 3, but in that order, which would fail if you wrote 3 and 1. You can check that every single item in the list matches a given matcher. They're all positive in this case. If we introduce another type of iterable, in this case a set, you will see that I'm not going to run every single assertion individually because it would take too long, but trust me when I say this passes. You could see that the set is not equal to the list because they're not the same type of iterable, but in that case you would use contains, which is similar to if you just wrote is equal to. And what contains does is it checks that it has the same length and the same items. So that since this set is a linked hash set, that means it's insertion ordered. So it will have these items in that order. So this will work. Similarly, you can do this again with matchers. It has first an item less than 2, then an item less than or equal to 2, then an item greater than 2. You can also do contains but in any order. So it has to have that number of elements. It has to have 3 elements, but it can have them in whatever order. And you can also do like the reverse type of checking on iterables that the actual value is one of these values. So it's kind of similar to to has item, but here with has item the actual value is the iterable, but with is one of the actual value is the item of the iterable, right? So and you have also the same, but which takes a list and not a variable argument array. So you've got also matchers for maps. Say you have this this map of mappings from a type of fruit to how many you have of that fruit. You can check that you have apples in your map. You have the key apples. You have again, it can also take a matcher, a key starting with apple. Anywhere in your map you have the value 5, or you have the entry mapping from oranges to 5, or that the map has a certain size. And also, since arrays and lists are not very directly comparable, in Java you have similar matchers for arrays as you have for lists, but they're called different things. So you can check that an array is not empty, or it's empty. It has a certain size, it has a certain item within it. It contains all these other items in order, or it contains them in any order. Let me know, by the way, if I'm going too fast or if anything is not working for you. You also have logical operators. You can check that a value is either matches this matcher or that matcher. Foo either ends with R or U. So this either takes 2 matchers, any of takes however many matchers. And you've got the same for and. You can check that it's both starting with F and ending with U, or that foo is all of starting with F, containing O, and has 3 characters, has length 3. Finally, you've got type checking. You can check that this string is an instance of the string class. It also works with superclasses. Any is just an alias to instance of for readability, and is an alias of is instance of. So you can check that an object matches a type. Yeah. And there are some other niche matchers. You've got check that a double is close to another double within a certain confidence interval. Check that a double has the value not a number. Comparison equals, for those of you who are familiar with Java, you know that if something implements comparable, it can return -1 or 0 or 1 depending on whether it's before or after something else when you compare them. So compares equal is just a different implementation of equality. You can check that a value, when you call toString on it, returns the given string. You can check that that a class is compatible with another class, that a string matches a certain regular expression pattern. I don't know why they have 2 different methods for this, because they're implemented in different ways, but they do exactly the same. But there are 2. And you've got several others. I see I'm spending more time on this than I intended, so I'll move on from Hamchrist now. But you can also, just to mention that, you can write your own matchers if you want, which can be useful in some cases. You can, do I have that anywhere? I don't. Yeah, I don't think you've got like an arg that matcher, which is useful for just delegating to another matcher. But I don't have time to go into that. So I'll move on now to the next tool I wanted to show you, which is Maketo. So up until now, I've been showing you like the different the tools for testing values within a layer. Maketo allows you to test communication between layers, or between any class, between any pair of classes really. But it's very useful for testing between layers. So say you have a temperature service, and that service calls the converter from Celsius to Fahrenheit, or vice versa, and it also accesses the repository where you, which accesses the database. So we've got a couple of constants here, just to, I'll come to that. We're also then, what's important here is we're mocking the different classes that our temperature service depends on. So if we're mocking the temperature converter and we're mocking the temperature repository, and then we're passing those mocks into the constructor for the temperature service. What that allows us to do is it allows us to stub the behavior of these classes that you depend on, so that you can test the class that you're interested in, temperature service in this case, without triggering all the dependent behavior, like triggering the rest of your application. So, to demonstrate, if we have, say you instantiate an expected temperature reading, you expect that when you call the repository, you get this list of readings back. Then you stub the repository mock in such a way that you say that when you call fetch all temperatures on the repository mock, then the repository mock will return this value, this list of readings. So this is stubbing in Maketo. It's the when. This is short for Maketo.when, but it's more readable when you import it statically. And then you can perform the actual calculation, service.get all temperature readings, which should call repository mock, and then you assert that what you expected, the results you got back using Hamcrest, is equal to the results you expected. So this is what I've demonstrated here, is when you mock, you stub the behavior of the repository you depend on. The other thing that you could do with Maketo is to verify a function call. So if you say that you want to store a certain temperature reading, say store the temperature 5 degrees Celsius at the current point in time, then you can verify that you have made the method, you have performed the method call on your repository mock, store reading, and passed it any temperature reading as a parameter. So that's the other thing you can do with Maketo, is you can check that a method has been invoked with a certain argument. Obviously you can combine them. You can say that when you try to convert from Fahrenheit to Celsius on the converter mock, then just return a constant 10, whatever the input is. And then you call store current temperature from Fahrenheit, which should convert the Celsius, which should convert the Fahrenheit input to Celsius. And then you check that on the repository mock, store temperature reading method was called, and its argument is an argument that matches this, saying that Celsius is 10 degrees Celsius. So you have stubbed the converter, and then you verified in the repository that the expected method was called. And here you see this is the Maketo arg-that matcher, which is very flexible. It passes you in the parameter into an anonymous function, and then you can just do whatever match you need on that. You can check that methods have been called in order. So if you store current temperature from Fahrenheit, you want to check that first you convert the temperature to Celsius and then you store the reading. You don't want to just store the Celsius reading as just the direct Fahrenheit. So to do that, you use the Maketo inOrder class. You can check, let me see. So you can check that, yeah, so you can use, so for time can often be an issue when you're testing because time passes, right? So if you're depending on a certain point in time in your test, then that test might fail later because the time value you get out is later than it was when you wrote the test. So to avoid that, you can use a fixed clock. That's what I have at the top here. That's when you say that you instantiate a clock with a fixed value whenever that clock is, whenever you get a time reading from that clock, it's always the same time. And the way you use that is that in your service, you basically say that you pass in a clock when you get the reading of the current time. So when you do that, that allows you to write better tests. It allows you to write tests that take time into account. So here you can say store the current reading, store 5 Celsius as the current temperature, and then you can assert that the call to store reading is 5 degrees Celsius and the time is now. You've fixed that time. Right. We have. So we also have the in Maketo the argument captor, which so you're mocking a method and then you're calling the method under test, and then you're checking that you're creating an argument captor, which you use in the verification phase, and what that does is it stores the value which was passed in to this method. So you want to check that the repository, that store reading was called on your repository mock, but you also want to know what the value was so that you can use that for further assertions later. So here I'm capturing the value, and then later I can extract that value and get a field from it and make an assertion on that field. In this case, it's kind of a contrived example. You could do this, like you could achieve the same thing using argthat. So often argthat is what you want, but argument captor has its uses sometimes. I think I'll leave it at that for Maketo, so I have time to go through some of the other things. So we'll look at database. By the way, I'll make all of this code available, like the repository I'll make available and the slides I'll make available. If you feel like you're not seeing everything, you can check this out later. And I'll leave a link to it later. Is there a question? No, you're just holding. Oh. Yeah. Okay, so say you want to test your database. You want to test this here, this communication between your repository layer and your data store. In this case, you can't very easily do that with the tools you have at play normally. So maybe the first thing you might go to is just instantiating a local database and testing towards that. You might run up a local database in Docker, for example. Check that we don't have any database running, and you start a database. And then you can run this test that looks into the seed directory for. So okay, I should explain Flyway first. For those of you unfamiliar with Flyway, it's not really a tool which is specific to testing, but it's extremely useful when you're testing your database. Flyway is a database migration tool. And what it does is let me see if I can find it. This is a Flyway migration script, and you'll find it's just SQL, right? It's just SQL. What it does is you can say this is the initial state of my database. You have these tables, you have these views, whatever your database is made of. And then later you can add more scripts saying this is how I change the structure of my database. And that's very useful to make sure that in every single different environment, your database looks the same, because you have this tool Flyway that makes sure that it applies the migrations it hasn't already applied, so it keeps the database looking the same in every single environment. And you can use this in testing. You can use this to say that when you have a completely fresh database, like I just created, it will pick up that database initialization script, run that to create the table, and then since I've specified this seed location, it will go to this seed folder and run these migrations as well. This is just, I'm inserting a single row into my table. So what's happening then is at the start, this Flyway test annotation is picked up. It accesses my database. Since I'm using the Spring framework, so through Magic, I've said you can find the database at this URL, log in with this username and password. Then Flyway will go to that data source. It will pick up that there are Flyway migration scripts. It will run those migration scripts against the database, and it will run this seed data. And then you've got a database in a state that you know what the state is. And then you can run a test against the data, against your repository, fetch all temperatures, and then you will expect that the reading you get back has this time and this value, because that's what you put in the seed. That time and that value. And then you can assert that they're true. So if we run that, it'll fail because I have disabled it, because you have to actually start the database first. Otherwise, it will always fail. So now that passes, what it did was it accessed the database, it ran the Flyway migration script, it called the repository layer of our code, ran the SQL to fetch all the readings from the table, and checked that the result was as expected. So this is a very useful test. It's a very useful method for checking that your SQL code is as it should be, that it works as you expect. However, it's not really very useful or practical to have to run up manually an external database every time you run your tests. So this is not necessarily the best way to go about it. We shut down that external database. Maybe we could figure out something else. So another alternative is an in-memory embedded database. An example of that is the H2 database. So again, since this is Spring, there is Magic, these annotations which just instantiates an H2 in-memory database, which is not an external database. It's a database that runs in Java. But it, again, since you have this annotation Flyway test, it does the same thing. It accesses the Flyway db/migration path for all the migrations, database migrations. It runs those, and then it accesses the seed location, and then you can run your tests in the same way. Fetch all the temperature readings and expect that they are this value. And this is this will also work. It's faster because, well, it's certainly more practical because you don't have to run up an external database. The downside of using this approach is that the in-memory embedded database, it's its own database implementation, right? So it might not have the same support as your production database. It might have its own certain quirks. In an example from my project, we use Postgres, a database in production, and we use the XML data type of that database. And H2 doesn't support that. So we couldn't use this approach because the H2 embedded database doesn't have support for that type. So the Flyway migration script would fail. So it's a useful approach in certain cases, but my preference is the one I'm going to show you now, which is it's the same approach, but you start up a containerized database, but you start it from your code and not manually. So what you're doing is you're creating, using an external library called test containers. You'll find this in the README to this code. You'll also find it obviously in the Gradle build, Gradle.build. It's these dependencies. You run up a Postgres container using a JUnit class rule. The class rule just says before any tests are run, do a certain thing, and then after all tests have been run, destroy it again. You can rules and class rules are very useful. There are certain predefined ones in JUnit. You can write your own. They're quite powerful. And to ensure that your JDBC template, which are used by your repositories to talk to the database, to ensure that that gets access to the Postgres container you just created, you have to configure it with the URL, username, and password of this container. So it's a bit much to take in. It's a bit of config, but it is quite powerful in that it allows you to run up in a Docker container, but from your code, initiated from your code, you run up in a Docker container a database of the same type that you use in production. So you're testing exactly the same behavior. The test itself is the same. You check that. Oh, actually, no, it's not the same because there's another thing I wanted to demonstrate, and that is that you can use a test repository. So here I've got two different types of repository. I've got the normal repository, which is used by the TemperatureService normally, and then I've got a test repository, which is only used in tests. And what the test repository is used for is it's got the same function as the seed earlier, except it's more flexible. The seed, you have hard-coded a folder with all your different table insertions, row insertions. With the test repository, it's just you have a method that you call to insert whatever into your database, but you can call it like wherever and insert whatever. You don't have to create a new folder and write new SQL every time. So this is a method I find quite useful, like not using, you don't have to change your main repository and add a method that wouldn't be used outside of testing. So I prefer to just create a separate repository that's used purely for testing, purely for instantiating the database state. So using the test repository, I insert this row. Then again, we fetch all temperatures and we expect that the value is as we expect it to be. So when we run this, the Dockerized Postgres database is spun up and it fails because okay, didn't work now. Normally works. I don't have time to troubleshoot it. That's some of the issue with database tests is they can be a little bit finicky sometimes, and I'll obviously demo Ghost. But yeah, so this is the approach I prefer. This is the approach we use in my project. You run up a containerized database locally from your code, and then you perform verification and assertions against that, because then you verify the same code that would run in production, which is what you want to test. Also, I like to have a test not only for the repository layer, not only for this layer, but also for the actual code in the database. So if you've got in your init script, I've got these constraints. I say that the date time column has to be unique. You don't want two readings on the same time in this case, and it has to not be null. The Celsius column has to also not be null, and it has to be above absolute 0. You don't want to have like negative Kelvin degrees. So I find it useful sometimes to have tests for my SQL constraints as well. And you can do that in much the same way. You run up a database and then you run just plain SQL against the database. So here I've taken a different approach again. Here I'm running up a Postgres container, but this time I've said in a properties file to use that the database, the data source driver is the test containers driver, and it's found at this URL. So then I don't have to, in my tests, configure the data source URL, username, password, because the test containers library takes care of it. So that's another way to go about it. So here I've got this. So before each test, Flyway is run, and then I've got this code that just inserts into the database, and then we've got a number of tests that just check: can I set this column? Can I set this value to null in the database? And see if this one works. The issue with these database tests is they take time because you're running up Postgres in a container, right? It takes a little bit of time. But this passes. So we see that you expected a data integrity violation exception, basically saying you broke a constraint, and that's what you expect, and that's what you get because you passed null into a non-nullable column. I have several more of these, but I'm going to move on now to a mock MVC example. So I've shown you tests for value assertions, interactions between classes, interactions with the database. I'm going to show you now attests for interactions with the API. Using Spring's Mock MVC. So this is not only Java specific, this is Spring specific. So I don't know how many of you use Spring. If you don't, this is not going to be super helpful to you, but if there are similar libraries and other in your language of choice, then I guess the concept is transferable. So what you have here is you're testing your controller. So you're mocking out, using Maketo, you're mocking out the service which your controller depends on. And then you're creating a Mock MVC instance based on that controller. And what that allows you to do is, so you just mock your service saying, when you call get all temperature readings, then return these predefined readings. And then with Mock MVC, you can say that you perform a get request against this path, this HTTP, an HTTP request against this path. And when you get the result, you can print it for debugging purposes. And you expect that the content of the HTTP response is a JSON string equivalent to this one. So it's a list with a timestamp with an ISO 8601 formatted datetime and a Celsius property with a double. And if you run this, so this is useful for testing that your controller responds to the requests that you expect with like the correct HTTP method, the correct path, and it returns the JSON responses that you expect, or XML or strings or whatever, but normally JSON. Yeah, I wanted to talk more about that, but I've been spending more time than I intended. The final thing I want to demonstrate is packed. So that's this interaction here between the consumer and the API. So this interaction, which is like, it's kind of similar to what I just showed you with Mock MVC, except here the test is not defined within your provider. It's defined by the by the consumer. And so this technique is called a consumer-driven contract. And it's a contract that is defined by the consumer that says that the provider has to meet these expectations of the API. And if a change is made to the provider that breaks those expectations, then the test fails and you cannot deploy the provider. So it gives an API consumer veto power over changes to the API level of your provider. So you only basically want to use this if you only want to use this normally if both the consumer and the provider are controlled by the same people, right? Are controlled by your organization or your team. Because if an external party is the consumer, then communication with them gets difficult, and you just get like people blame each other. But if you can collaborate properly, then consumer-driven contracts are a good idea. And I think I have time to demonstrate it. I'll see. So I've got that in a separate repository, not a separate repository, but a separate application. So let's see. Here we go. Okay, so this is using the packed framework for consumer-driven contracts. So you define your consumer and your provider. The application we've been looking at so far has been called, I've just called it climate because it deals with temperature. The consumer is called grapher because it graphs the temperatures. You have some setup code, and then you define a rule that connects the provider to a host. All of this is kind of boilerplate. And then you define the actual pact. So you say, given this a state that matches this string, given that there exist a few temperature readings, upon receiving a request for all temperature readings on this HTTP path with this HTTP method, you expect the HTTP response to be a 200 OK response, and you expect the body of the response to be a JSON array with at least a single element, and the element must match the following. It must be an object, and the object must have a field a field of type timestamp with name timestamp. I could have called it something else for disambiguation, but I didn't. And the timestamp has to match this pattern, year, month, day, the ISO 8601 pattern. And it also, the object also has to have a number with name Celsius, and here's an example of that number. So you, in the consumer, we're looking at the consumer now. In the consumer, you define this contract, and then you run a test that, the test does two things. It converts from this Java domain-specific language that we're seeing up here to a JSON file that expresses the same thing. And then it also just checks that this works on the consumer end. Like if you mock the API client, then and it returns the values that you yourself specified in the pact, then it doesn't break the consumer. The consumer shouldn't write a pact that itself cannot consume, right? And then what this does is it, let's see, it puts is it in here? No. Oh no, it's on target. It puts this, it generates this file, graph.climate.json. So this is consumer-provider.json. And if we look at it, it's a JSON file which specifies the pact. It has an interaction, it has all the stuff. And then you can copy that from here. Let's see, copy to source test resources pact. So you copy this pact from the consumer to the provider, and then you can go to the provider to a pact provider test, and it picks up on it picks up on the pacts within this pact folder that you just copied the pact to, and it defines. I know I'm going through this a bit quickly now, but I'm out of time. And it defines a state that matches the state that you defined, like the string here matches the string from the consumer. And then you can say that when I get in a request for this state, then I want the service to return these values. I want it to return a temperature reading with 2 temperature readings in this case, with this time and this value, this time and this value. And then here in this test, you don't define any tests explicitly. You just define states, and then tests are generated from the pact file in this case pacts folder, and then they're run, and we'll see if it passes or not. And if it doesn't pass, then so in this case it passes. If it didn't pass, then you've made a change that breaks an expectation of a consumer. So you should collaborate with the consumer to make sure that you don't break something for them, maybe you should like stagger your update so they have time to change to a different version of the API or something. It's a bit annoying to have to like manually copy a pact from one folder to another. It doesn't really scale. So the pact framework also offers you something called a pact broker, where the consumer uploads the pact to a third entity, and the provider downloads the pact from that entity, which is just a layer of abstraction, but it means you don't have to like communicate these pacts manually between all the different consumers and providers. But I don't really have time to show you that. So I'll briefly finish off the presentation. So I demonstrated, apart from JUnit, I demonstrated Hamcrest, which like makes assertions on all the different parts, the different layers. Maketo, which performs stubbing and verification between layers and between classes. Test containers, or the H2 embedded database, or a similar database, there are others, which you use to test the code from between your repository and the data store. Mock MVC, which you use to test your controller code. And then finally, the pact framework, or more generally, consumer-driven contracts, which you use to test the communication between applications, between microservices, between a consumer and a provider. So, if you want to look more into any of these, here are the sources for them. I've included a couple of others here that I haven't talked about, and frankly haven't used that much myself, but I know that they exist. And these Evo Suite and Evo Master are tools for automatic generation of tests. Evo Suite is for unit tests. Evo Master is for integration tests. And what they do is they, using an evolutionary algorithm, they just bombard your application with randomly generated data and see what passes and what doesn't, and it just assumes that the code as it is right now is correct, and it generates tests based on that. And if that behavior changes later, then those tests fail, but you know that you've changed some important behavior. So if you're interested in that, it might be worth looking into. If you want to check out some of the stuff I didn't have time to cover, or you want to see these slides, here are the URLs. Take a picture if you like. Otherwise, that's what I had. We're out of time, but I'll take questions if you have any. Thanks. That's it.